Linked list is a collection of nodes where each node is connected to the next node through a pointer. Node means which are going to store an information. So each data item in nonlinear data structure is called as node. Tree is a collection of nodes and it can represent hierarchy relationship. E, F, I, J, K do not have any child node, then we can call it as is a leaf node or terminal node. Welcome back to my last session of data structure. I am Shweta, Computer Science faculty, Vidhyaashram College, Mysuru. In my last session, I have discussed about the operations of linked list, that is inserting a node and deleting a node into the linked list. So today I am going to discuss about the nonlinear data structure. Already in my previous session I have discussed about linear data structure. So what do you mean by linear data structure? Linear data structure is a data structure all the datas are arranged in a sequential order. In linear data structure, all the datas are arranged in a sequential order. Examples, we have arrays, stacks, queues and linked list. How to represent the array? A of 0th location, A of 1, A of 2 and A of 3. Here we have 4 locations. A is the name of the array. Here I will take 10, 20, 30, 40. This is the way of visualizing an array. So array means collection of homogeneous elements. So array can hold multiple data elements, and also I have explained about stacks. Stack is a linear data structure. It follows last in first out mechanism, LIFO mechanism. So example, here have one stack 0, 1, 2. So here top of the stack is 2. I will add the elements. In stack, the addition of new elements and the deletion of an existing element always takes place at the same end, that is top of the stack. In this example, so top is 2. Addition means pushing an element into the stack, that is called as push operation, and removal of an element from the stack is called as pop operation. So this is the representation of stack, and also I have discussed about queues. Queues follows first in first out mechanism. The element which you are inserting first has to be removed first. So queues follows first in first out mechanism, FIFO mechanism. Queue is a linear data structure in which elements are inserted from one end called rear, and the removal of an existing element takes place from the front end. So two operations can be performed in queues, that is addition of new elements from the rear end and deletion of an existing elements takes place from the front end. And also I have discussed linked list. So what do you mean by linked list? Is a collection of nodes. Linked list is a collection of nodes where each node is connected to the next node through a pointer. So linked list is having two parts, that is data and link. In data part, so here data has to be present, data or information. Link means in link part it finds the address of the next node. So example, start means it is connected to the beginning of the node. Example, I will take 10 is my data, and here link part finds the address of the next node. So last part is null. So this is the representation of linked list. So, in my previous session I have discussed about arrays, stacks, queues and linked list. So, these are the linear data structure, and today I am going to discuss about the last topic called nonlinear data structure. So, what do you mean by nonlinear data structure? Nonlinear data structure is a data structure in which elements are not in a proper order. Elements are not stored sequentially. So, there is no contiguous memory allocation of the data. So, what is the meaning of nonlinear? Nonlinear data structure is a data structure in which data elements are not stored sequentially. This is called as nonlinear data structure. A nonlinear data structure is a data structure in which data item is connected to several other data items. So, here one data item is connected to several data items, and the data items in nonlinear data structure represents hierarchical relationship. Next I will tell what is the meaning of hierarchy. So, nonlinear data structure follows hierarchical relationship. All the data elements in nonlinear data structure cannot be traversed in single run. It is having multiple levels, but linear data structure is having only one level, but nonlinear data structure is having multiple levels, and it is represented in hierarchical relationship. Each data item is called as node. In nonlinear data structure, every data items we can call it as is a node. Node means which are going to store an information. So, each data item in nonlinear data structure is called as node. And the different nonlinear data structures are trees and graphs. So, linear data structures are arrays, stacks, queues and linked list. Already we have discussed in my previous session. Nonlinear data structures are trees and graphs. So, nonlinear data structure is a data structure in which each element is not stored sequentially, and it represents hierarchical relationship. Examples for nonlinear data structures is trees and graphs. So, first one we have trees. So, first nonlinear data structure is trees. In actual trees we have root, branches, leaves, etc. Like that, in data structure tree also we have root, branches, leaves, siblings, parent, child, etc. So, what is tree? A tree is a data structure. Tree is a data structure consisting of nodes organized as a hierarchy. Tree is a data structure consisting of many nodes and organized as hierarchy relationship. It represents hierarchy relationship. Tree is a non-linear data structure and it represents hierarchy relationship. A tree is a hierarchical relationship that naturally stores the information in a hierarchical fashion. Is a collection of nodes linked together to simulate a hierarchy. So, what is the meaning of hierarchy? You can take an example for college employees. In the first level we have director, below director we have principal and dean, and below dean we have HODs, and below HODs we have faculty members. Below HODs we have faculty members. Here faculty members can report everything to HODs. HODs can report everything to dean and principal and dean can report everything to director. So, this is called as hierarchy relationship. So, here I will take B, C, D, E, F, G, H, I, J and K. This is called tree. Tree can represent hierarchy relationship. Is a collection of nodes. Here we have so many nodes. Is a collection of nodes. Tree is a collection of nodes and it can represent hierarchy relationship. A tree is a nonlinear data structure and is a collection of nodes to simulate a hierarchy. This is called as tree structure. And next we have terminology of a tree. This is one tree structure, right? We have so many terminology in tree. So, first one is node. So, what is the meaning of node? Node is a fundamental part of a tree. Node is a fundamental part of a tree, and each element of a tree is called node of the tree. Here each element of a tree is called as the node of a tree. Node is a fundamental part of a tree. Node is nothing but the fundamental part of a tree is called as node. And root. So what is the meaning of root? The topmost node of the tree is called as root. The topmost node of the tree is called as root. This is called as root. Generally, the actual tree grows from the ground into the air, but in data structure tree grows from top to bottom. Clear? This is called as root of this tree. So root means the topmost node of the tree. Topmost node is A. A is called as root of this tree. So root means the topmost node of the tree is called as root. And the node which is not having any parent, then we can call it as root. The node which is not having any parent, then we can call it as is a root node. This is not having any parent node, we can call it as root node. Root means the topmost node of the tree and it is not having any parent node, then we can call it as root node. And next we have edge. So what is the meaning of edge? Edge means link between two nodes. Link between two nodes, we can call it as edge. Link between two nodes. Then we can link between two nodes is called as an edge. It connects two nodes to show that tree is a relationship between them. It connects two nodes. Link between two nodes, we can call it as is an edge. And parent. So parent node. What is the meaning of parent node? You know about parent, right? It is an immediate predecessor a node. Immediate predecessor. In linear data structure, have discussed about successor and predecessor, right? In linear data structure, each element is having one predecessor and successor, then we can call it as linear data structure. Each element is having predecessor and one successor. So for 3, predecessor is 2 and successor is 4. Except first element and last element, other elements is having predecessor and successor, right? So we can call it as is a linear data structure. But in trees, we are not having one predecessor and one successor. We will get one predecessor and many successor. Then we can call it as is a nonlinear data structure. So here parent node means is an immediate predecessor a node. Immediate predecessor. So for B, the predecessor is A. For C, predecessor node is A. The immediate predecessor node is known as the parent node. B and C, immediate predecessor is A. So A is a parent node for B and C. And B is a parent node of D, E, F. Immediate predecessor a node is known as parent node. C is a parent node of G and H, and H is a parent node of K, and D is a parent node of I and J. So parent node means is an immediate predecessor a node, then we can call it as is a parent node. In this example tree, A is a parent of B and C, clear, and C is a parent of G and H. Immediate predecessor a node is called as parent node. I hope you are getting my point. Node, root, edge and parent. Node is a fundamental part of a tree, and root means the topmost node of a tree is called as root, and the node which is not having any parent node, then we can call it as is a root node. And edge. Edge means the link between two nodes is known as an edge. And parent. Parent means is an immediate predecessor a node, then we can call it as parent node. So A is a parent of B and C, and C is a parent of G and H. And next we have child node. A successor of a parent node is called as the child node. A successor of parent node is called as child. Here A is a parent of B and C, and B and C is a child of A. We can call B and C is a child of A. That means a successor of parent node is called child node. Successor means these are the successor for this parent node, right? The successor of parent node we can call it as is a child node, and DEF is a child of B node, and GH is a child of C, and K is a child of H, and IJ is a child of D. This is called as child. Child means a successor of parent node. Then siblings. So siblings means a nodes that are children of the same parent. You know about siblings, right? A node that are children of the same parent. Children of the same parent means, so B and C is a children of the same parent A, right? So DEF is a children of the parent A. DEF is a children of the same parent B. This is called as siblings. And grandparent. So what is the meaning of grandparent here? Siblings means the children of the same parent. So here C is a child of A and A is a grandparent of G. Understand the concept? C is a child of A and A is a parent of C, and also A is a grandparent of G. This is the hierarchy relationship. And leaf or terminal node or external node. Leaf or terminal node or external node. Nodes that do not have any children. The nodes that do not have any children, then we can call it as leaf node. Nodes that do not have any children. For I, J, E, F, K do not have any children node, right? Then we can call it as is a leaf node or external node. So leaf node means here E, F, I, J, K do not have any child node, then we can call it as is a leaf node or terminal node. The node which is not having any child node, we can call it as is a leaf node. E, F, I, J, K are called as leaf node. The node which is not having any child. Next we have internal node. A node has one or more children is called as an internal node. A node has one or more children. A node which has one or more children, then we can call it as is a non-leaf or internal leaf. Node which has one or more children. Node which has one or more children, we can call it as is a non-leaf, and node which has one or more children. So the H is also a non-leaf, D is also a non-leaf, but E, F, G, I, J, K is a leaf node which is not having any child. Non-leaf means which is having at least one or more child, then we can call it as is a non-leaf or internal node. And next we have path. Here I will write the tree structure again. So B and C is a child of parent A, and B is having 3 child D, E and F, and C is having G and H, and again I, J and K. So here path is an ordered list of nodes that are connected by edges. So path means a sequence of consecutive nodes from source node to destination node. Sequence of consecutive nodes from source to destination. Example, what is the path of J? What is the path of J node? That is A, B, D and J. So this is the path. This is a path of J, A, B, D, J. This is called as path. And what is the path of K? A, C, H and K. A, C, H, K. This is the path of K node. Path means sequence of consecutive nodes from source to destination edges. This is called path. And next we have height. The height of depth of a tree is defined to be the maximum number of nodes in a branch of tree. Maximum number of nodes in a branch of tree. So, here we have only one node, here we have two nodes, and here 1, 2, 3, 4, 5 and here 1, 2, 3. Maximum number of nodes in a branch of tree. So, here maximum number of node is 1, 2, 3, 4, 5. In this figure, the maximum number of nodes in a branch of tree is 5. This is called height of the tree. And next we have ancestor. One more question, what is ancestor and descendant? Ancestor means any predecessor from path to root of that node. Any predecessor. So, what is the ancestor of F? That is B and A. What is the ancestor of G? That is C and A. Any predecessor from path to root of that node. Then we can call it as ancestor. So, here ancestor of D is B and A. Ancestor of F is B and A. Ancestor of G is C and A. And ancestor of I is D, B, A. This is called as ancestor. Any predecessor on the path to root of that node, we can call it as ancestor. And descendant. So, what is descendant? Descendant means a node reachable by repeated proceedings from parent to child. A node reachable by repeated proceedings from parent to child. Any successor node on the path from that of root node to leaf node, we can call it as descendant. Descendant means any successor node from path node to that of leaf node, we can call it as descendant node. Example, what is the descendant of C? That is G, H and K. That means any successor path node from that of leaf node. Leaf node means there is not having any child. So, it is not having any child node. This is not having any child node, we can call it as leaf node. Any successor node path from that of leaf node, we can call it as is a descendant node. Example, for C, descendant node is G, H and K, and for D, descendant node is I and J. Only you need to consider successor node, not predecessor node. So, only you have to consider the successor node of path node to that of leaf node. We can call it as is a descendant node. And subtree means a subtree is a set of nodes and edges. Is a set of nodes and edges. Is a set of nodes and edges comprised of parent and all the descendants of that parent. All the descendants of that parent. So, subtree is a collection of nodes and edges. So, here this is one subtree and this is one subtree. This is T1 and T2. This is one subtree and this is another subtree. I will call this is T1 and this is T2. This is called as subtree of the main tree. T1 and T2 is called as subtree of this diagram. So, subtree is a set of nodes and edges. So, these are the terminology of a tree. You can expect for 1 marks and 2 marks. So, what is the meaning of path? What is descendant? What is an ascendant? And what is a child node? And what is a parent node? So, these are the terminology of a tree. Very simple concept. Please understand the concept in tree. It's just like our actual tree. We are having child, parent, root node and branches, leaf and non-leaf, right? So, like that we can represent a tree like this. So, this is called as hierarchy structure. So, tree is a collection of nodes So, tree is a hierarchical relationship that naturally stores the information in a form of hierarchical fashion, and this is called as trees. And next topic is binary tree. And what is the meaning of binary tree? A binary tree is an ordered tree in which each internal node can have maximum of 2 child nodes. Internal node is having maximum of 2 child nodes. So, I will consider this is one internal node, it is having 2 child nodes. So, what is the meaning of internal node? The node which has one or more children, we can call it as internal node. So, binary tree is an ordered tree in which each internal node can have maximum of 2 child node. So, is an ordered collection of tree in which each internal node is having maximum of 2 child node, we can call it as is a binary tree. So, B and C is a binary tree in this diagram. So, B is having 2 children and C is having 2 children and A also is having 2 children called B and C. Clear? This is called as binary tree. So, first node is root node and this is called as binary tree. Binary tree means a node which has 2 or more children, we can call it as binary tree. And binary tree consists of a node called the root node. A binary tree consists of a root node and left and right subtrees. Here this is called left subtrees and this is right subtree. So, binary tree consists of a node called the root node and left and right subtrees. Binary tree consists of left and right subtree. And what is the meaning of complete binary tree? A complete binary tree is a binary tree in which each leaf is at the same distance from the root. Each leaf is at the same distance at the root node, we can call it as complete binary tree. And in complete binary tree, all the nodes have maximum of 2 subtrees. All the nodes have maximum of 2 subtrees, we can call it as complete binary tree. So, this is called binary tree and complete binary tree. And last concept in this chapter is graph. Graph is a nonlinear data structure, is a collection of vertices and edges. Graph is called as a collection of vertices and edges. Graph is a set of vertices and edges which connect them. So, you can see the graph here is a collection of vertices and edges. So, this is called as edges and these are the vertices. So, this is called as vertices. Graph is a collection of edges and vertices. And a graph is a collection of nodes called vertices and connection between them called edges. So, graph is a collection of nodes called vertices and connection between them called as edges. And we have 2 methods in graph, that is direct graph and indirect graph. So, what is the meaning of direct graph? When the edges in a graph have a direction. Direction graph means when the edges is having a direction in the graph, we can call it as directed graph. You can see the direction of this graph. Directed graph means when the edges in a graph have a direction, then the graph is called as digraph or directed graph. This is one example for digraph. And undirected graph. In an undirected graph, the edges are bidirectional. So, bidirectional means there is no direction for this particular vertices, then we can call it as undirected graph with no direction associated with them. No direction associated with them means there is no direction for the particular node and hence it can traverse in both the directions. So, 5 is traversed to 6, 7 and 3 also, and so 2 is traversed to 1 and 3 also, and 3 is traversed to 4 and 2 also. This is called as undirected graph. Undirected means with no direction. Directed means with direction, we can call it as directed graph or digraph. So, this is called as graph. So, today we learnt trees and graphs. Trees terminologies, we have path, edges, height, subtree and siblings, parent node, child node, etc. And in graph we have studied directed graph and undirected graph. So, this is called as nonlinear data structure. In linear data structure, all the data are arranged in a sequential order, but in nonlinear data structure, elements are not stored in sequential order. With this, we have end of this chapter, data structure. In my next session, I will come with a new chapter. Thank you.